So in this video I want to show three strophoids associated with a triangle and it's Cevian, it's X Cevian. So here I'm showing the X sub 1 or in-center Cevian of ABC, whose vertices are the midpoints of the Cevians through the triangle center X sub 1 and the opposing side. So I have my X1 Cevian here, A prime, B prime, C prime. I could have made my X2 Cevian, which happens to be the medial triangle, or the X3 Cevian, and so forth and so on. But let's now stick with the X1 Cevian just to illustrate how I'm going to be building these three strophoids. So the first strophoid is going to have focus on A, and it's going to have its node at this opposing or opposite vertex of the X1 Cevian, and the auxiliary line is going to be BC. So I can put a point on this auxiliary line and draw a line through it, like so, and then draw that circle that goes through my node. So this is, we went through this on the previous video. And now what I need are these two intersections of the circle with this line. Now let me see if I can find them. I thought I had these. So maybe this is the first one and this is the second one. So here they are. You can see here the two intersections. And the motion of these two intersections, the locus of these two black dots here, is going to sweep out my strophoid. So let's go ahead and show that strophoid. There it is. And now I can turn off. So first of all, I can just show how the strophoid is swept by those two intersections. And now I can turn off these auxiliary objects. I'm lucky enough I can find them. So I'm going to turn off this line. I'm going to turn off PA. And I know there's a better way to do this in GeoGebra, but I'm a little lazy. And let's turn off those 2 points because they don't really help us with anything, right? Those two intersection points. Let me just locate them. This one over here, let's go ahead and not show it. And let's not show this one over here because it's immaterial. So the cool thing is that now I have a strophoid. Okay, let's call this the A-strophoid associated with a triangle ABC, specifically vertex A, and its X1 Cevian. And of course I can go ahead and draw, and I've already done this in behind the scenes, I can draw the B-strophoid, which is the exact same construction, and the C-strophoid. So I can repeat that red strophoid construction cyclically for the three vertices. And I get, in general, a triad of strophoids, and there's nothing really interesting about them. You can see here that they are, intersecting with each other, etc., etc. They have outer intersections as well. They could be of some interest. It seems like these outer intersections are defining a new triangle. So this could be studied. But here's the interesting harmony that one discovers as you flip through these X sub k's to get a different Cevian triangle. So if I go to X2, the medial triangle, I don't perceive anything extraordinary here. You can see that each strophoid is going through its node as expected and its focus. Okay, so but they don't interact in any remarkable way. But as I move forward to X3, let's go ahead and make this triangle be less obtuse. I don't see anything remarkable either. Let's go to X4, the orthocenter. So this is the orthic triangle. The Cevian now is my orthic triangle, and you can inspect this. You don't see anything special. So as you move forward, okay, X5, X6, when you hit the Gergon point, X7, a really nice harmony happens. Now, all the strophoids are passing through the three vertices of, this is called the intouch or contact triangle. Why? Because it's actually marking, its vertices are marking the touch points of the incircle of this triangle, like so. Let's make this incircle be a little nicer. Let's make it be gray, perhaps, and let's style it a little bit and make it be like so. So here's the incircle of this triangle, and you can see here that whatever this triangle might be, for this construction of this strophoid triad, you get a nice triad whereby each one of them passes to the other contact point. So you could, in principle, turn off the other two strophoids and just focus on this property here, which is repeated cyclically. What is that? If you have a triangle ABC and you get the A prime vertex or the A prime intouch point, okay, of the incircle of this triangle. So here's the A prime intouch point, and you make that be the node of a strophoid with a focus on A and a baseline through the side BC. This strophoid is guaranteed to pass through the other two touch points of the triangle. Okay, so if you repeat this cyclically, the same is going to happen for the second strophoid, like so, right? And cyclically for the third strophoid. You can see here that now my node is C prime and passing through the other, the alternate touch points, A prime and B prime. So of course, if I draw the three of them, you get this beautiful phenomenon. So here's the first harmony between strophoids. There's a run point. Remember that the intouch triangle is also the pedal triangle of x1 of the incenter. But here I'm just accessing it via the Cevian of the Jordan point. So here's a harmony between a triangle, the intouch triangle, and the triad of strophoids. Now, I've been told by Professor Liliana George, not related to Gergon, that these three intersection points also have interesting properties, namely that they're homothetic to the original triangle. So if you draw this intersection here, for example, this intersection there, and this intersection there, and you build a triangle out of these, this triangle seems to be mysteriously homothetic to ABC. Okay, so these results might be evident, obvious, but I thought this was a neat property. See you on the next video where we're going to talk about quadrilaterals and strophoids.